Tom Campbell here. I and M.I.T Events hope you like this video. It was made possible by donations from our supporters. If you're one of them, thank you so very, very much. If you're new to M.I.T and find something of significant value in our videos, please consider supporting their production through our Patreon account or through a one-time donation. It would be very much appreciated. The links are in the description below. Thank you.
Good afternoon, Tom. Thank you for being here. Today we're looking at a couple of questions from some of our Patreon subscribers. And one question in particular is very interesting, and I'd like to give a little bit of background on it before I read you that question. I know that when you first started writing My Big Toe, your theory that consciousness is the computer was something that no one had really established yet. You referred to Edward Fredkin, whom you mentioned, in many of your lectures. Just a little background on Edward. He left Caltech at age 19 to join the United States Air Force to become a fighter pilot. This career brought Edward to the Boston area, where he was assigned to the M.I.T Lincoln Laboratory, where he became one of the early computer programmers. Edward's visionary ideas are revolutionary theories that helped shape the field of computer science and artificial intelligence. He was a leading proponent of digital physics, also advocating that the universe could be conceived as a vast computational system. His work on reversible computing and the concept of digital philosophy challenged traditional notions and paved the way for new frontiers of scientific inquiry. Can you tell us a little bit about how Edward Fredkin's work influenced you and when it did, and also what the implications of it are?
Okay, sure, I'd be glad to. His work really didn't influence me. He published the paper called A New Cosmogeny, which had these ideas in it in 1992. And I actually started writing on my books probably 95, 96. And I didn't know that Fredkin existed when I was writing my books. It wasn't until I got to my last section of my last chapter, my last part of the book, the last section of M.I.T, that I started looking at what other people might have thought that would either support or refute, what I was saying. Then's when I discovered Fredkin and was pleased to find him, because he had part of the problem. He said that our reality is computed, that reality is a computed thing. And what he said is that, physicists before Fredkin thought that time and space were continuous. A lot of things weren't. A lot of things were not continuous. Matter of fact, everything seemed to be not continuous except time and space. And physicists thought that these were continuous things. And Fredkin said, no, if you go down to enough, if you go further down into the detail, if you get further and further resolution into our reality, you'll see that time and space are both digital. In other words, they come in pixels. They're not continuous. They're made up of individual pixels with nothing in between pixels. So he was the first physicist to state that seriously. And his work led him to write this paper in 92, A New Cosmogeny, which basically said that time and space are pixelated, and that this reality is computable. And if it is computable, it probably is a computation. And he had his evidence in this paper that that was true. He talked about it and gave arguments of why that seemed to be a good idea. Now, when he dealt with the question of, well, where's the computer that's computing it? He said the computer was any place other than here. And then he shortened that just to say other. It was in other. But that means any place other than in this computed reality, because a computed reality can't contain the computer that's computing it. You see, that's just logically doesn't fly. So the computer reality had to be someplace else, and he called that other. So I thought that was a good idea. But what he didn't understand, that was very necessary to get the big picture. What he didn't understand was that consciousness was the computer. He just knew that this was a virtual reality. Now, he didn't say the word virtual reality, but in 1992 and in the 1980s before that, we were playing stick figure video games. The idea of a virtual reality hadn't actually gelled yet and wasn't talked about. It really wasn't a concept at that time, particularly when he was doing the thinking about this stuff, which was probably the decade before, in the 80s, and maybe even go back to the 70s. But so virtual reality wasn't a thing then that really existed. All of our computer games were a bunch of little stick figures running around in real, jerky motion, and the fact that you could actually compute a reality hit him as we weren't there yet. It wasn't a concept. So he just said that our reality was computable because it came in discrete chunks. Therefore, the only way you get discrete chunks is if you compute it. So that was kind of his argument. He said everything else that we can measure comes in discrete chunks, but not time and not space. And he said that's just because we can't look at the small enough level to see it. And then, of course, quantum physics had this idea of Planck time and Planck length. And many people, not all, but many people in physics said that Planck length and Planck time was the distance and the time at which our reality became granular, which means breaks up into pixels, the same thing. So now it was pointed out that Planck length and Planck time didn't make that a fact, that it had to be pixels, but that was kind of the general interpretation, that that's the time and place. If you could get down that small, if you could look down around a unit as small as a Planck length and as small as a Planck time, that you would see the pixelation of our reality. But a lot of physicists didn't like that interpretation because it kind of tore up their materialist viewpoint a little bit, that it was computed, and the material wasn't the thing. So that was kept at arm's length. But he was a very smart guy. Matter of fact, he was so smart that he very early got into the rise of computer systems and information systems and so on, that he was still a very young man in probably M.I.T, I guess. And he made so much money. He started a company. The company boomed, as all tech was booming in that time around communications technology, that somebody bought him out for a very large amount of money. And suddenly Edward Fredkin was a rich man. He was very rich. So at that point, he was in these universities, but he was very unique there. He just wanted to do research. He was a very smart guy, and he just wanted to do research. He didn't want to teach. He didn't want to go to faculty meetings. He didn't want to do any of that stuff. He just wanted to do research. And M.I.T got a little cross with him because he wouldn't take teaching assignments. And I think he eventually left there because he didn't fit into their idea of what a professor should be doing, because he wasn't interested in teaching. And I think then he went to Boston University and a few other places. But see, he didn't have to worry about his paycheck. If M.I.T wanted him to do something he didn't want to do, he could say, see you later, because he was independently wealthy at that point. So here's a guy who doesn't really have to care about what his peers think. He doesn't have to care that he's not a materialist in a world of materialist physics. So he had this unique position where he could say it just like he thought it was. And he could say it with impunity and with force. And if you don't like it, who cares? So Fredkin was an unusual guy. And they said that he was an important part of digital physics. As far as I know, he created digital physics. It was around him that digital physics formed. He was the founder and the leader of the digital physics movement. And the digital physics movement was actually growing and taking place at the same time I was writing the book, because I had a little interaction with a couple of them when I was in the process of writing the book. I found out about them, ran across digital physics, and I hadn't yet run into Fredkin, but I ran into them. And I passed a few things back and forth to him about free will, of all things. And we had an argument with some digital physics graduate students about free will when I was writing the paper. So anyway, Fredkin was an unusual guy, a physicist who could speak his mind the way he saw it. And the way he saw it was that this reality of ours was computed. Now, another 20 years later, 30 years later, the concept of virtual reality came around, and saying that a reality is computed is the same as saying that this reality is a simulation, which is the same as saying that this reality is a virtual reality. Those are all equivalent statements. A computed reality, a simulated reality, a virtual reality all mean exactly the same thing. So Fredkin was really positing a virtual reality back in the 1990s because of his understanding that space and time were digital.
So on the subject of free will, our question from Bashan, our Patreon supporter, focuses on the stimulus studies that are out there. And I want to give a background of a few papers by some neuroscientists and others, and another, on what has been done with the Libet experiment. So Dr. Peter G.H. Clark, a neuroscientist, has written a paper on the Libet experiment and its implications for conscious will. And by this, they are meaning free will. In the paper, he points out that this has been a controversy, that the original results indicated that there was no free will. But when Libet looked further into this experiment, he noticed something very interesting. There appeared to be a small loophole in the experiment that involved a veto or an intervention. He therefore argued that even though the initiation of the movement in this stimulus experiment was not the result of conscious will, its vetoing power was. So that's one experiment that I'm going to leave, and you can comment on, and I'm going to leave a link to in the description. Another is interesting article, and I was pleased to see that it was Scientific American that did this article. It's by Steve Taylor. He's the author of Spiritual Science, Why Science Needs Spirituality to Make Sense of the World, and published in Scientific American. What he does is give a little bit of a background on how this idea, this concept of free will, that we have no free will, where it really started. One of the most fervent of late 19th century materialists, T.H. Huxley, described human beings as conscious automata or automata with no free will. As he explained in 1874, volitions do not enter into the chain of causation. The feeling that we call volition or will is not the cause of voluntary act, but the symbol of that state of the brain which is the immediate cause. This was a very early formulation of an idea that has become commonplace among modern scientists and philosophers who hold similar materialist views, that free will is an illusion. According to Daniel Wegner, for instance, the experience of willing an act arises from interpreting one's thought as the cause of the act. Many people believe that evidence for a lack of free will was found when in the 1980s, scientist Benjamin Libet conducted experiments that seemed to show that the brain registers the decisions to make movements before a person consciously decides to move. In Libet's experiments, participants were asked to perform a simple task, such as pressing a button or flexing their wrist. And it goes on. I'll condense this a little. This experiment appears to offer evidence of Wigner's view that decisions are first made by the brain, and there is a delay before we become conscious of them, at which point we attribute our own conscious intention to the act. However, Libet looked at this experiment, his own experiment, more closely. And Wegner says if we look more closely, Libet's experiment is full of problematic issues. For example, it relies on the participant's own recording of when they feel the intention to move, and so on. In another modified version of Libet's experiment, participants showed readiness potential, RP, even when they made a decision not to move, which again casts doubt on the assumption that the readiness potential is actually registering the brain's decision to move. You've had an interview with Dr. Ian McGilchrist, and it was a wonderful thing to note that he was on board with consciousness as fundamental, as your theory states. A further, more subtle issue has been suggested by psychiatrist and philosopher Ian McGilchrist. Libet's experiment seems to assume that the act of volition consists of clear-cut decisions made by a conscious, rational mind, but McGilchrist points out that decisions are often made in a more fuzzy, ambiguous way. They can be made on a partly intuitive, impulsive level without clear conscious awareness. But this doesn't necessarily mean that you haven't made the decision. As McGilchrist puts it, Libet's apparent findings are only problematic if one imagines that for me to decide something, I have to have willed it with the conscious part of my mind. Perhaps my unconscious is every bit as much me. And I think what he's meaning by unconscious here is what you use as consciousness. Why wouldn't your will be associated with the deeper, less conscious areas of your mind, which are still you? So, because of such issues as these, McGilchrist goes on to say, it seems strange that such a flawed experiment has become so influential and has been misused so frequently as evidence against the idea of free will. Now, let me bring you to the question that we have so you can comment on this from the question that Bashan has submitted. What is the message when the body starts to move before the stimulus arrives? Libet is a stimulus experiment. How does this relate to consciousness? His thought is the body gets programmed over time and has a mind of its own, but that consciousness has programmed it over time. And what would your interpretation of this and what these neuroscientists have said?
Okay. It's good to talk about this particular experiment and case that Libet did, because, the reason that the guy in the 1800s wrote, the reason, that scientists have come to this conclusion that free will must be an illusion is because they had to. They didn't really have any good reason for that other than to maintain their belief in materialism. If you are a materialist, then logic demands that you think that free will is an illusion, consciousness is an illusion, and time is an illusion. Okay, these must all be illusions and not really exist if materialism is correct. And that's because materialism must also be determinism. A materialist also has to be, logically, a determinist. Those two go together. Well, so the physicists had been told by logicians and other people in the field of logic that it was obvious that materialism really wasn't a fundamental thing, because obviously we have consciousness, we have time, and we have free will. So the physics community, that's usually the scientists that they're talking about, would be the physicists. They worked and thought very hard to come up with some way that they could get rid of free will, time, and consciousness. Okay, and because those things are just incompatible with materialism. Well, they weren't very successful. None of their arguments would hold much water. They looked at some of Einstein's equations and tried to interpret them in a goofy way that supported their theory about all of time happens together. You know, the past, the present, and the future is all at the same time, which of course doesn't make any sense either. Just those words themselves, the definitions of them depend on time, not, time being real. Past is past, and it happened before the present, and it, the future happens after the present. That's just part of their definition. So anyway, the scientists have struggled to come up with some interpretation or something that verified this point, and they're interpreting some of Einstein's equations, made them feel a little better, but still, that was just kind of a wild interpretation. Wasn't necessarily the way the world worked. And then Libet came up with his thing, and oh my, the physicists just jumped right on that with both feet and said, we've got it, proof that free will doesn't exist. Okay. And of course, Libet didn't have his work published more than a few months when all sorts of other people disagreed with him. And they disagreed with him enough that he went back and re-looked at it, the issue. And after he re-looked at the issue, he disagreed with himself. He said, oh yeah, you're right. My work does not show that, free will is an illusion. It doesn't show that, because the people had the ability to veto what the action that their supposedly will had started in the brain. They could turn that off if they wanted to. So he said, okay, you still have free will. You can still say no. These things, okay, it started earlier before the stimulus, but you have the will to say no. And if you have the will to say no, well, then you must have the free will to say no. So he changed his mind on it, and people continued to write papers mostly about how Libet's argument about showing that free will couldn't exist because of his work with readiness potentials was not true. Had a lot of things about it that just weren't true. So this, as McGilchrist said, it's a failed science. Now, it doesn't say that. There's lots of explanations for what happened, but all of those are kind of hand-waving. They're not. They're reasonable in the sense that they show that it doesn't have to be the way Libet said. It could be different ways of why this readiness potential even exists. But none of them actually addressed, why does this readiness potential exist? Why is it that before my arm moves up, before I even think about moving it up, a readiness potential, that is little potentials deep in the muscle tissue, start to change in readiness for my arm to move. And that happens a little bit of time before I decide to move my arm. And this was what led Libet to say that, well, then there can be no free will, because the will to move the arm was starting to take place before the mind was even aware that it wanted to move the arm. You see, well, these readiness potentials are there because, now this is Tom Campbell's theory of readiness potentials, because the larger consciousness system had evolved these almost perfect avatars for the individuated units of consciousness to go play in, to go make their choices for them so that they could improve the quality of their consciousness. And that worked pretty well, except these electromechanical bodies that you had in this virtual reality. Remember, the virtual reality isn't programmed. Our virtual reality evolved. It evolved from a set of initial conditions and a rule set. The rule set's physics, chemistry, biology. So it evolved from these rules and those initial conditions. And it just was what it was. How it evolved is how it evolved. So it turned out that most of them became extinct. Well, we are very slow. I mean, consider us and all the other animals. Almost every other animal sees better than we do, hears better than we do, has much faster reaction times than we have. We are slow to react. We're slow to move. We don't hear well. We don't see well. We don't smell very well. Most other animals can have all the senses that we have, and they have them to a much higher degree. Their sense data is more sophisticated. But here's this avatar that was going to be the avatar for the IUOCs, and it just was slow. So in order to get the human avatar up to speed, now we're still slow compared to animals, but we were even slower then. The system, larger conscious system, which is can we say modeling this, it's producing this virtual reality. It's modeling our reality. It's doing the simulation of our reality. So consciousness is the computer that's computing the virtual reality. And it wanted to speed us up, and it did so by getting us going in those old, slow electromechanical systems a little earlier before we decided to move. So that potential is just the system trying to speed us up to the point that we have more reasonable reaction times. So that little readiness potential is something that the rule set required in order for the humans to be more viable in the world, so they could be a little faster in their reaction times to things. So that is what the consciousness does. It does that for us. It added that. That's a little fix to the simulation, so to speak. So that's my idea or theory of why that readiness potential is there. I mean, this whole reality is simulated. And it's simulated with a rule set. But according to the rule set, we turned out to be kind of clunky and slow. So the system cheats a little and gets us going a little faster so that we will be better avatars, have more interesting choices. Otherwise, we wouldn't be able to drive cars. We wouldn't be able to fly, jet aircraft, or all those things would be just require much faster reaction times than we have. We couldn't play sports. We were just slow. So this is part of our rule set now, was the fact that our bodies get started early before they actually have to move to start moving. And that's that readiness potential.
That's the consciousness. Consciousness is faster than the speed of light.
Well, consciousness is much faster than the speed of light. Consciousness, if it has any time things that would slow it down at all, it would be at the Planck time, a little delta t. Okay, it may have to take some delta t's to get its things done, but delta t is like 10 to the minus 44 seconds. That is, 10 to the minus 9 is 1 billionth of a second. 10 to the minus 44 is like a billion, 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 you know, a billionth of a billionth of a billionth of a billionth of a second. So it's so small. That's where we start, you know, that's our maximum resolution. Now, the system doesn't make our simulation all at that resolution. That would be terrible. There'd be so much data it would have to compute that nobody would care about because it was too small for us to interact with. So when it does the simulation, it does it at multiple levels of resolution in order to optimize the efficiency of the computing. So it has that level, but this delta t would be something that the consciousness would work with. But that is so fast, it makes light speed look like frozen molasses, you know?
Well, this applies to remote viewers, instantaneously remote viewing across distance.
Oh, sure. Remote viewers will tell you what's going on in Alpha Centauri, which is what, I forget now, 4 light years away, something like that. It's a small number of light years away. But still, in order to see that, it would take their mystical sense at the speed of light, you know, a light year or two to get there, and then a light year or two to come back. And that's not the way it works. It doesn't take them years to get the result of their remote viewing of what's happening in Alpha Centauri. But it's the closest star to us.
Yeah.
So everything else is further away than Alpha Centauri. No, you can remote view things. And there were some experiments that had to do with how fast did this psi information travel. And I think they showed that it was, I can't remember whether it was using some of the astronauts in space where, you know, because you had Mitchell who was interested in these kinds of things. And I don't know whether it was that or whether it was just them being far apart on the globe and they were able to tell. But there's been a few experiments done that show that consciousness works much quicker than the speed of light because it's not part of this virtual reality. The reason that the speed of light is as fast as you can go in our virtual reality is because that's 1 pixel of distance for every pixel of time. To move 1 delta x takes it 1 pixel of time, and that's as fast as you can go through. If you went 5 delta x for 1 pixel at a time, now you'd be teleporting. You'd be disappearing at this pixel and reappearing 5 pixels later. And everybody would be winking out and reappearing someplace else if we had that kind of a thing going here. But that's every virtual reality has a speed limit. And it's 1 pixel of distance for 1 pixel at a time. Our pixels are really, really small. 10 to the minus 44 seconds is just an incredibly small amount of time. And our pixel of distance is what, 10 to the minus 36 meters. Well, 10 to the minus 36 meters is just, again, what, 4 nines are 36. So it's 4, a billionth of a billionth of a billionth of a billionth. 4 of those. And going to 44, it's actually 5 billionth of a billionth of a billionth of a billionth of a billionth. Well, you know, you break something into a billion pieces, and then you break that 1 billionth of a piece into a billion pieces, and then you break that 1 billionth piece into a billion pieces, and so on. You can see we're talking about things that are way smaller beyond our ability to perceive or to comprehend. All right. Now, that delta t is the clock that consciousness has. Consciousness operates at that delta t. So if consciousness takes any time at all, now to us, it's so fast that it seems instantaneous. Just instantaneous, because it's many, many orders of magnitude, you know, faster than light speed. So many orders of magnitude faster than light speed that light speed, like I said, would look like, you know, something that was frozen. Gilchrist says, I just can't understand why people just keep clinging to that old flawed research. Well, they keep clinging to it because they're believers in materialism, and they just can't let that go. You know,
well, that speaks to a good scientist. Libet took another look at it and
said he was wrong.
That's
yes.
amazing.
Yeah, that's good science.
Because usually, you know, if you wanted to be popular, you just hang on to whatever
right.
it is that
So
made
good.
everybody happy,
Yeah, good for him. But
Yeah.
I tell you, the physicists hung on to it. They said, "Well, here we got an experiment that shows that we're right. Free will can't exist. Now all we need is an experiment to show that consciousness can't exist and that time doesn't exist." But obviously, those positions, free will, time, and consciousness, don't exist, are silly. They just run so counter to everyday experience that then to say, yes, well, it's just a very clever illusion. We think they exist, but it's a very clever nonsense.
You know,
They exist. We all know they exist. If there were no time, there is no learning. There is no evolution. There is no before and after. Nothing ever changes if there is no time. Well, what kind of reality is it that nothing ever changes? A
a
dead,
machine.
useless, well, not even a machine that's broken, maybe, a
A
machine that
machine
doesn't
that's,
work. Yeah, if it's a machine
I'm
that
sorry,
works,
it
then there's
stopped.
time, or it doesn't work. Yeah. So there's nothing. You see, it's the
Yeah.
dead zero reality of nothing ever changes. So
Well,
it's
the
totally
other
useless.
interesting, yeah, it doesn't make any sense at all. The other interesting thing was what you brought up from your theory that humans, as they evolved and consciousness could log on to these avatars, they needed a boost. That
Yeah.
physical aspect wasn't enough. They need, in order for there to be a smooth, um, workable sort of smooth, workable sort of actions, that consciousness had to be upgraded, or
Yeah.
or what would you say? How would you put it?
Yeah,
I don't know if that's the right way.
upgraded is probably a good word. It needed that readiness potential needed to be there, and it needed to be there ahead of the action in order to speed up a very slow, clunky process, which is this electrochemical process. You have little potentials, and they spread through the nervous system, and you have chemical things, hormones, and other things that have to move through the circulatory system. And our bodies just, we're a pretty big animal. We're bigger than dogs and cats. Well, we're not bigger than lions, but we're bigger than domestic dog and cats anyway, who can move a lot quicker than we can. But big animals have more mass and there's more inertia. So we tend to move more slowly, and we just needed to speed up a little bit. So I think the system came up with a way to help us move faster. And okay, we got that. And now we're more capable, and we can make better avatars than we would have otherwise. So I think that's probably why things like readiness potentials are part of our biology. It's that part that helps us start a slow electromechanical system moving.
We are always consciousness, but that particular assist to the human avatar needed to be there. That particular aspect, because we are consciousness in an avatar playing in this virtual
Yeah.
reality, but there was something missing that didn't allow enough of a quick response to be productive.
Mhm.
Would you put it that way?
That aspect of the rule set and the initial conditions producing a useful avatar, it made a pretty good avatar, but it needed to evolve a readiness potential to help it go sooner. And if it wasn't a consciousness system, it couldn't do that. There would be no way to evolve something to make you go faster. But it was a consciousness thing. So the consciousness thing, it's being simulated. It is modeling our reality. So it can make things move a little faster if it wants to. It's modeling, it knows what's, we make choices, then we execute those choices. And in that process, it moves, what did we say, a billion times faster than the speed of light. So it's got all the time in the world to help us get going. You see, it can just sit around and watch those people just, trying to move their hands someplace, and it can speed that process up because it is simulating. These avatars are just simulated, but they're simulated according to a rule set and a set of initial conditions. So that rule set and those initial conditions just needed to create this readiness potential. Consciousness can do that because it's the rendering engine to just move us along a little quicker because our bodies are slow. And here we are, so we have this peculiar thing in our physiology called a readiness potential. And a little bit of potential starts to get us going before we even know that we need to get going. But the system knows we need to get going because the system is computing all of it. Everything's computed. And we make a choice, and that's consciousness makes the choice. But that choice is so fast, that choice is so immediate, that getting the avatar going to represent that choice, the computer has a lot of lead time that it can do things like that. In other words, when we play video games, there's this thing called video lag. Remember in the old days, not much so anymore, but in the old days when computers weren't as fast as they are now, there was video lag. You tell your elf to jump, and your elf would just sit there, and then a second later it would jump. That's video lag. You put in the command, but it took a while before that command went to the computer. The computer then sent it back to draw the elf jumping, right? That took enough time that you'd punch the jump button and then wait for 3 seconds before your elf actually jumped, called video lag. As you got faster and faster computers, that video lag got smaller and smaller and smaller and smaller. Okay, well, it's sort of like that. Your computer is much faster than the action that's going on in real time, then it has all sorts of time to play whatever tricks it wants to make things happen the way it wants to happen. It's the rendering engine. It can make things happen more quickly, but it has to connect that to the physiology somehow, because everything the humans do has to be connected to the rule set. We are just produced in a computer. Our body is just computed in a computer, but it's according to a rule set. So you have to now make up a rule that says the body has to get going before the body even knows that it's supposed to get going. Otherwise, those humans are just going to be slow, pokey individuals. So it's just the way computers can work to make things work better. It's a consciousness computer. Now, it would be hard for us to make video games, be able to guess what the player is going to do. But remember, in consciousness, the player is part of the larger conscious system. The player and the computer are all part of the same system. So what that consciousness is thinking about and what it wants and what it's going to do, that is a very, very fast system compared to our system. So that can then be put into our system easily, you see. So
such interesting analogies.
Yeah.
I wonder if that readiness potential upgrade was needed for that flight or fight response that is inherent.
Oh, I'm sure it was. It was needed for us to stay alive.
Yeah.
Like I say, we are slow compared to most of our competitors. And all of the things that were higher than us on the food chain, there were some things a lot bigger and faster and meaner than we were that were in those times, like saber-toothed tigers perhaps. And, cats have very quick reaction times. And we needed to react more quickly, or we weren't going to survive. So the system gave us a little boost to enable us to do that. So we evolved to have this readiness potential, part of our system, so that we would start this slow process that has to happen in this long, process from little tiny potentials at the muscle have to start there. Well, we just had to start that a little quicker, a little earlier. And they could do that because it was a conscious computer and it was a conscious player. And the computer and the player were all part of the consciousness system. And that system moves very fast compared to what we were simulating here. So it was just easy to do.
That's such an interesting theory, how you've set it all out. Well, Bishan, thank you for your question. I'm sure you will agree it has evolved into a much more complete picture of your question, but thank you very much, Tom. That was great.
Well, you might notice, I say that this model of reality solves all sorts of paradoxes. Well, that readiness potential is a paradox. Why do we have this thing that starts moving before we even know that we need to start moving? You see? So that's a paradox. It's there. Science can show it. It's there. But why is it there? You see? Well, this model shows why it's there. But nothing else shows. Now, all these other papers that took Libet to task about his conclusions, they had all kinds of other reasons why it didn't work, because his methodology was a little flawed. But nobody ever really explained why we do have that readiness potential that starts ahead of time. And why does that happen? So that was just another one of these, paradoxes lying on the table that we don't understand.
Only
but
that
this
it
model
existed.
but this model gives an answer for that, of how that could, how that could take place and why it had to take place. It wouldn't be there if it didn't have to be there, but it needed to be part of our evolution.
Well,
the system that's modeling our evolution can do what it pleases, particularly since it's so fast compared to our big fat delta T here in this model. Our model, that our delta T that drives this simulation we call the physical universe, is huge compared to the tiny little delta T that drives consciousness. So the consciousness computer has billions and billions and billions of cycles in its consciousness computer for every single cycle that our virtual reality we call the physical universe has to be updated. Now, we think ours is pretty small. Planck time, whoa, that's really small. That's our delta T, 10 to the minus 44 seconds, but it's that's really pretty slow compared to the clock that runs consciousness.
Thank you, Tom. That's just one more application of your MBT theory that we had not discovered yet. Thank you very much.
I and MBT Events hope you liked this video. We will continue to post videos for free on my YouTube channel, but please understand, these videos are expensive to produce. They represent many thousands of hours of production and editing, as well as all the necessary audiovisual equipment, computers, and software. If you find something of significant value in our videos, please consider supporting their production through our Patreon account or through a one-time donation. It would be very much appreciated. The links are in the description below. Thank you.